están conectadas con el fraude de ninguna manera, en absoluto. Son solamente...
Hola, hola.
Hello, and please remember to vote for the speakers with the crowded tool.
¿Qué eventos cobran esas editoriales? Bueno, el evento más sencillo es el de la impresión. Una impresión es cuando un usuario ve el anuncio. Puede ser un banner, puede ser vídeo. Eso es bastante barato. Un poco más caro, el clic. Cuando el usuario hace clic, ese es otro evento. Y el último evento del que voy a hablar, y el más caro, se llama conversión. Una conversión significa que el usuario hace lo que queremos que haga. En el mundo de las páginas web, eso consiste en registrarse, rellenar un formulario, por ejemplo, una plataforma de citas. No solamente van a poner un vídeo, también querrán que el usuario se registre. Si el usuario hace clic y se registra, esto es una conversión. En el mundo de las aplicaciones móviles hablamos de instalar y activar aplicaciones que tienen publicidad incluida. ¿Quién crea este tráfico fraudulento, ese 33% del que hablaba antes? ¿De dónde viene? Bueno, una de las fuentes es el de los desarrolladores de malware. Son tecnológicos, son sofisticados, conocen el mundo de la publicidad suficientemente bien como para explotarlo y, por supuesto, ganan dinero con ello. Y ganan dinero fácil. Crean amenazas.
Vale, de acuerdo. Bueno, pues empezamos ya con...
Okay, so let's begin with Paúl Santapau, who's going to talk to us about pure DevOps. A big round of applause for him, please.
Bueno, buenas tardes, ¿me escucháis?
Good afternoon, can you all hear me? Great, thank you. I am Paúl Santapau. I'm here to talk about DevOps, and I'll give a brief introduction on DevOps, as I see it. And then I'll talk about security, and about how within the methodologies or the DevOps culture and practice we can include security items. Just like Ramon, I'd like to do a little survey, but just take into account development, security and operations. Could you please raise your hand if you identify yourselves as developers? Okay. Could you please raise your hand if you identify yourselves as people who work in ops? Okay, what about SEC, people who works in security? Okay, makes sense. We are a rooted Kong after all. Okay, so I'll talk about myself for a bit. And currently, I'm talking about continuums. I'm working on continuum security. We're working on tools to have security DevOps. I've worked as a security architect for 2.5 years for a British company, and before I was working for the John First University at Castellón, where I was dealing with electronic signature, cryptography tools, pen testers, and also ISO 27001, the boring part of security. You may find some more information on LinkedIn, and you can also add me there if you want. So I'm going to talk about 3 things. First, I'll give a few hints about how we got to DevOps and what it is. Where are we at? And I'll try to relate that to security. Where is security left and where are we at? In the second part of the speech, let's try to do some agile risk analysis in DevOps to direct our deployments and our continuous delivery of value, and eventually I'll do a little demo, quite interesting, where we search a continuous entry flow of functions to see how we can have checkpoints and security controls throughout that flow. Initially, I'd like to talk about a survey called Business Security Maturity Model, done in 95 large companies such as Adobe, HP, Cisco, very large companies. that compare here between each other to see where there are acts regarding security practices in software development, what we usually called OPSEC. The interesting bit here is not just the framework they use, which is quite interesting, but rather the figures they give regarding the mention of the security development and testing teams in large companies. So they give figures regarding how many people make up the security department, development, and testing departments. And here, in average, we have 1 people in security for every 245 developers. So 1 security person needs to test everything that 245 people do. That's in large companies. In smaller companies, there is no people for DevOps, and there's no people for security, and half the people for DevOps. There are 3 companies that are reference point in the world of DevOps, and they gave us data regarding how many deployments they can do per day. The Gov.uk website does around 10 deployments a day. The developers develop the functionality, it goes to their flow of steps, and then they deliver that functionality, 10 deployments per day. Etsy is an online art e-commerce, and they can deploy 50 times a day. And then we have Amazon. In 2011, they confessed that they could do a deployment every 11 seconds, which is about 300 deployments per hour. So think about those figures, and where will Amazon be in 2017? And how can we deliver functionalities in production? And how can we cope with all that from the security point of view and follow that rhythm? Our aim is that we want to gain speed. We want things to be in production quickly. We want everything to be fast. But we want to do that in a way that the functionality we give is not risky for the business. Our functionality works well, it behaves well in stress situations, it is coded for the burden we're going to have, and it doesn't represent a risk for the company, it will not have security problems. So what happened here, from classical methodologies, models such as a waterfall model, until what we have nowadays. I'm going to go through all of them. And in the waterfall methodologies, as you may all know, we have different stages. The methodology is executed sequentially to go from A to C. We need to go through B. We have analysis and design stage, where we design what will be done, then implementation and testing stages to carry out the development of that function and test it. And then we have the deployment stage and maintenance. That may be cyclical. As a later stage, the last stage where we correct things may appear and we may amend the software. Security-wise, it is very comfortable because the only thing that we need to do is to follow the development team in this process. So initially, in the analysis and design stages, we give the security requirements, make sure the design is correct, and that we don't get security things there that will be hard to correct in a more advanced stage of the process. Implementation and testing, we do the follow-up of those requirements, and in the final stages of the deployment and maintenance, we check that everything has been delivered as mentioned, and in maintenance we do a pen test, or we just test that the application is not representing an additional risk as time goes on, because we discover new things, either because we're forced by a regulation or because we have the caution in this company cycle to do this continuous testing. My message here is that this is quite simple security-wise. We can do follow-up and manage it in a reasonably good way. So from this we go to agile methodologies, where we have product backlog that is usually agreed between the product owner and the customer. The design is not well defined from the beginning, it's incremental, it is changed. In each meeting, or every time we need something new, we get a part of that product backlog and we add it to the sprint backlog, and we do a sprint, we run it to implement that functionality, and usually a sprint takes between 2 or 4 weeks, but it could only just take a day. Let's say we want to develop a functionality and we do a 1-day sprint. So mainly here we have a well-defined design from the beginning. We don't have a well-defined design from the beginning, but when it comes to assessing this from the security perspective, it's a bit more complex. We generate software versions per sprint. So for an agile development cycle where the sprints last for 2 weeks, we're going to generate a new software version every 2 weeks. So from the security perspective, what happens with these methodologies? We have the development team working at their own pace, developing, executing their own sprints, implementing functionality, and after a sprint is done, the security team detects security tests, and when we deliver the vulnerabilities report to development teams, they say, well, that happened 2 sprints ago. We're 2 versions ahead of the software you tested, so we're not going to correct that. It's a loss of time. You can check the application again and we can correct whatever you detect now. If we do it again, we get into the cycle again. It's so hard to do security tests that eventually we're assessing old software that is 2 or 3 versions behind the current version they're working with. So here we have a problem in application security when it comes to assessing security or implementing security issues and things in this development methodology. As if this wasn't enough, the development and the operations team get together, they agree, they begin to look for common tools to communicate, and they design this sort of pipeline where there are different stages, and they automate this as much as they can. So whenever the development people finishes with their sprint, this enables them to take this through the development and deployment flow. They organize different tests, they guarantee that the software works correctly, that it will send the stress we're going to put it through, as well as the number of customers, and this is deployed. So if it was already difficult to keep the security rhythm with agile methodologies, now with ops, if they do DevOps and they deliver continuous functionalities in a quick way, and let's remember Amazon, who does 300 deployments per hour in security, we're a bit lost. What can we do here? We need to look at how we can have different security checks in these stages to mitigate these risks. So these are typical pipeline. Just realizing that you cannot see the whole image. So we have the development part with the design implementation stage, the software construction stage, the unit tests stage to check the functionality of the methods implemented and the functions of the software code. Then the integration tests to check the integration between the components and whether it works appropriately. We have the acceptance tests done by the testing team, and then we have the production deployment done by the operations team, where we can check that everything works okay with regression or smoke tests. Just to check everything works okay, and this can be done in a cyclical way. And this is where we get the speed of the continuous value offering. So now what? We have very few people in security. We are working on lots of projects, and we need to validate and eliminate the risks when it comes to deploying production. So what can we do here? Well, this is where SECDEVOPS comes into place. We're going to add some security to DevOps. Some people call it SECDEVOPS, other people call it DevSecOps. but I would call it DevSec quality because it's about quality. You are adding quality to have more robust and well-working software that doesn't entail risks for the companies. And these people have a DevSecOps manifesto, which is on the internet, that says that we're going to reinvent ourselves in security. We're not going to be the blockers or the party poopers. We're going to get together with the testing operations teams who know how to deliver quick functionalities, and we're going to help them and collaborate all together. If a developer needs to implement a functionality and needs some cryptography, why shouldn't we implement a service deployed in our company so that all developers use that service, and the security team can do that in collaboration with the development team, so that we can help the developers and be the enablers in that case, so that when they come to us, we can give them a 200-page report with many vulnerabilities they don't understand that they need to correct, and we can say, well, you cannot deploy until you don't correct this. And apart from this, we have the philosophy of automating absolutely everything we can. In security, we cannot always automate everything, and there are things that represent a high risk that are difficult to automate. There are different vulnerabilities that cannot be detected automatically. But for mid or high risk things, if we have a risk classification framework, we can do certain things that give us security or mitigate the risk to an extent that we can be calm about. So that DevOps people use a toolkit. Using a toolkit is not doing DevOps, but these are the tools they use to automate processes, run through the deployment, and do it in a trustworthy way. So they use continuous integration services such as Jenkins, Bamboo, Travis, and so on. They use code repositories to manage and version the code, also orchestrators for infrastructure deployments to codify the structure and repeat it as often as necessary to escalate. Also cloud services for the same thing, to deploy quickly, test quickly, fail quickly, correct quickly, and deploy the functions needed. So what can we use from the security perspective? Which tools do we have to automate certain parts of the continuous entry flow? What we currently have as a split here is a split between commercial and open source tools. Regarding the commercial tools, these are the ones. There may be more. These are the ones I know best, and I've actually tried some of them. And many of them, especially the first few ones, are static code analyzers. You run the code through them, and they assess where the user impulses and how far they get through. If you use the buffers, you fill with more data than you booked, and you get some results. And you may launch this in an automated way, and the tool will do it.
Then there are tools like Iris Risk or Threat Fix. Iris Risk is an agile threat modeler, which helps us to follow the whole cycle. And Threat Fix it deals with vulnerabilities and understands very many tools, and you can use it to detect or analyze vulnerabilities detected with a different tool. Then we have the open source tools, and I'm going to focus on this specifically on BDD security and OWASP. Those are the two I will talk more about, and we will use in the demo to do some security tests within the pipeline that we're going to implement. We have different tools. Each technology we use, every type of test we want to do requires a different tool. So the problem of implementing these sort of things is finding the right tool for the pipeline we want to deploy. And then the problems that we get with these tools are, first of all, that we will find many common things. It's going to be difficult to find vulnerabilities with an automated scan, complex vulnerabilities in many cases. We will get a lot of false positives. It's another problem. And as a third problem we might encounter is how long it takes to execute. If you want to introduce this in the pipeline, you want this to execute in 1 or 2 minutes, because the people in dev and in ops, these are the margins in which they move. Those 5 minutes for the deployment of one functionality, we cannot launch a 45 static scan that takes us 2 hours. So it's quite difficult to take these tools to set them up properly and make them work within the functional deployment pipeline. So moving to the second part of the presentation, what I wanted to share with you now is how we can classify the risk of each application or each delta that we introduced in the application development, taking development into account to apply different security measures. And I show this slide because usually when I want a pen test, we actually don't know what we want, because a pen test means many things, just like the security measures are very varied. Depending on what we want, we can do different things. If we want to reduce risk in a maximum way, we can look for an expert in code vulnerabilities for that type of language and for that technology. If we want to simulate an attack, you can do a red in activity, and we will encompass more in the company, but the information for the red teaming will be basic, so they won't be able to get to the so much in depth. So they won't be able to decrease risk so much. And then there's the issue of if we want to increase our performance, the increase of controls and all that boring part of security. So how can we do this risk analysis to see what type of tests we're going to apply in the pipeline if of continuous delivery of functionality? Here, keeping in mind the traditional formula of risk calculation, the impact by probability, what we've looked for here is seeing how can we map each one of the two factors and how can we do it for a first swift analysis to see what's the risk entailed in this application. So impact can be covered with assets, because depending on the data that are being managed by our application is going to be more or less risk. And the probability part can be covered with the area on which the application is running, and I'll show you a diagram later on for you to see it better. But if we have a 3 or 4 layer architecture, it's not going to entail the same risk for the component in the DMZ than the one we have in the back end. There are 3 firewalls in the middle, and we have things checking on the level of activity. So assets and area. The assets and how trustworthy are the place where they are. Then we have a number of features of the application. If, for instance, we have an application that's being launched, that's launching SQL against the database, we think it's vulnerable to SQL injection, and therefore it would make sense to use those tests. And that's the part on the right-hand side, where I show the CWEs, the vulnerabilities it may have, and we will use that later on in the continuous deployment flow to decide which test we're going to launch. So based on that, and if we do impact by probabilities and take assets and zones into account, and this can take very, very long, because there's a lot of literature and internet. You can add impact, confidentiality, the traceability, the cost that it would entail an effective or material vulnerability. But Just to simplify and to show you sort of the basic elements, those are the only ones we're going to take into account. We can analyze risk as high, low, or very low. And most applications, just to give you a rough figure, 15 could be lower risk and 15 could be critical risk. And that happens because companies as such, we try to isolate the functionality that have a critical risk. For instance, if we're managing data of a credit card, we have a payment gateway, we're going to have that functionality over there, and there won't be many applications able to talk with this part. And so developments tend to have different levels of risk. And this is important because depending on the risk of the application, we will realize that the higher the risk of that application, of those features for our organization, the less we will be able to automate, and we will have to configure or set up the automation, and we might have to do things sort of manually. And if the risk is low, then we will be able to automate a lot more, because the assurance that we want and the risk reduction that we want is, in those cases, is not so crucial. We just need to detect that we think could be there, and that could be enough. So this is the architecture I was mentioning earlier on to refer to the data and the areas distinction. We have this three-layer architecture. We have an external DMZ, and then we have an intermediate area where we have the database and the domain controller. From the viewpoint of probability of having an attack or a vulnerability being exploited, it's easier to have an explanation, an attack on the proxy inversion than in the database. And the database can be more critical in terms of risk for our company if they exploit a vulnerability here than in the reverse proxy. If the database, for instance, has public information that you can find in the database in the web, it's not so serious. But if should I be hacked? But if what I have in that database is the one used for payments with credit cards, then yeah, that's obvious, you know. So what I have implemented for the demo is this concept. We have a service in Python where it exports that, it reads the property file, and what you can ask from this service is, tell me the risk, tell me the projects you manage, give me the risk for that project, and it gives you this meeting point between the highest possible risk regarding the data with the area that's less trustworthy. And that's what defines the pipeline deployment. And that may block one part of the development, etc. And then I've included here the CWEs, then a couple of dates when it was reviewed last time and when it expires. And those dates can be connected with the sprints or with the DevOps. And if the review has expired and we have done nothing about it, then the risk goes up and it may block. Okay, I'm going to introduce the tools that I'm going to use in the demo. I'm going to use two tools. One is OWASP Zap, which started as a proxy that you can configure in the middle of an application. It's for web application security, and what it does is it inspects the traffic that flows through, and it gives you security warnings, what things you could improve. It also has an active way in which you can give it an URL and you can say, give me a splattering of what you find and attack it with different policies. SQL injection to look for XSS, different policies. But what's so more interesting about this is not so much the proxy, but it's the fact that it's moving towards or evolving towards a framework. So it has a very complete API, and you can use it, directing it from other services. And we do that from the DVD security, which when it comes to, we're going to see a case in which one application has SQL injection. We will check that it really has it, we will correct it, and we will check again with the OWASP that it doesn't have it anymore. Then we have BDD security, which it's a framework. It's integrated with different tools, and one of them is OWASP. But it's also Nessus. You can launch scanners with Nessus. And what's interesting about BDD security is that it uses natural language to define the security tests. The developers understand it, the operators understand it, and those in security, we also understand it. So we use BDD, which is like an extension. We check the functionality of our code, and we check the behavior of our code. You have an example here. And a definition of a BDD testing would be to return an item when Jeff wants to return a faulty microwave because he bought the microwave and paid $100. He has a receipt and he returns the microwave, and we have to refund the $100. So with the security part, BDD security tries to do the same thing, and we can include things like for SSL, launch this command. I don't want it to have this type of vulnerability, and check, for instance, that the conversion is disabled so that we do not find the RIME attack. And that's also running on a BDD framework, which is called Cumbert, and it means that BDD security can use the tools that are there. And so we have reporting issues that are covered, and you will see that in the demo. And it's very easy for developers and testers, when one of these tests fails, to go there and see what has failed and correct it, and keep moving forward with the development. Another of the problem of automated tools is the login issue. Those of you who have used Arithmetic tools or X, you have struggled with the login when you want to scan a web application in which you have to log first, and we always end up by authenticating ourselves in the session, because if you want that to do login automatically, it can be hell. So BDD solves that by using the login. It opens the real server, and we program in Java, and we execute the login and you will see that we can say, let's go to this field, to this password, print, say OK, and that means that you're logged in. And if you are, then search this in the page, and this will be the key for you to realize that you're really logged in. It has a number of basic security specifications that can be used by default as default features, and then it's easily extendable with a bit of Java. You can know how it works. It's a no-brainer. And I'm going to show you already this from the. We'll do a couple of tests, see if they work. For the demo, I will be using Docker to simulate an environment. We're going to have an environment. I'm booting it because I will need it to show you some code executions and Intel IG But in the demo, we're going to have the Jenkins server. We will use the pipeline module, and we will define in what each one of the phases within the continuous deployment, and we will have a web application that we will deploy in pre-production. We will do the tests, and then we will deploy it. So I'll show you next. If we go back to the BDD security, this is what it looks like. Here you can see the code tree. I will start with the configuration file. And what we define here? First of all, the driver we want to use, what browser we're going to open with Selenium to do the login, what we have, the base URL. And this is an important parameter because this is the Java class that will implement all of the interfaces that will allow us to do login and to serve here. Some setting up of tools, how do we maintain the session, which is the default user, the URL, etc. Here we have also, but before I want to show you the class. This is the one that I have implemented for an application in the internet, which is vulnerable. And what it does is what I've told you earlier on. It extends this type of web application and implements this. And that's the iLogin. I log out and I navigate. So this gives us the method to be able to do login and navigate in the application. So we have a method that opens the login page, and what we do is we wait until the element with the ID username is in the page, and once we do that, we do a login, and that obtains the credentials of the file and looks for the element in the page. For the ID username, and we delete what's there, and then we send the current username, which is in the configuration. We delete the ID with password, and we send the one we have in the configuration, and then we find the submit, and then we click there. Then we have a method to see that the user is really logged, where we check whether the page in which we are contains the logout text. And then we have a method to do logout. You have to look for it, and then you click on it. And finally, the navigate element, that when we want to launch scanning or passive scanning of the application, we want to be able to say which are our application corners that perhaps wouldn't be detected, and to cover the whole application and to make all traffic to go through that security device. We can say take the basic URL, look for this text, click, look for the table element, and then you click here, and so on. We direct the application. I'm going to show you this. Let's see if it works and I don't suffer from the demo effect. We haven't talked about tests. We have them here in the features file or directory, and we have scenarios in which we have some sort of setup, and then we have the different tests, and we test different things based on what we're executing here. And here we can see that each one of these sentences, what it has behind is a JavaScript that supports whatever needs to be done in each one of those actions. For instance, here we can see that the authentication tokens have been deleted and have been removed, so we delete them. A new browser is open, and we generate the application, which is the one that will do the whole setup of the new navigator. Something else of interest is this that we're going to use in the SQL injection search, we can ask to remove false positives. We can say these are false positives and we do not want them to introduce a noise in the pipeline, and they will not make the test failed anymore. So we have different tests, authentication. Passwords are case sensitive. The login is sent through HTTPS. When we do login, the application gives us 302, and if we have to do a reload, we do not have to include the credentials once more. We have authorization issues where we can check that if we do login with user A and user B, they cannot see each other's information, things about security headers, host configuration, ports, headers, etc. So I'm going to execute SSL. This is also interesting. We can check that it's correct, that it's using protocols about which there's no serious vulnerability known. And I'm going to execute a text here, for instance, so this one. It will open two navigators, and I'm going to try to do the login because I'll have to register the user. So one of these has direct access to the configuration of the setup, and it opens the two of them, and depending on the test, it will execute one or the other. Invalid user name, because when I put the application, I have to register the user. Let's do that. And I will open the demo already. And the test is being launched on the production server, or what will become the production server, and this is the one. So we register that user, which is going to be the one that we have in configuration. So the user is registered, and what we do here, we do log out, and we run the test. Both navigators open up, and we're going to see that the login should be able to access the application. So if we have tab in the middle, the session is there already. And from then on, everything to do is going to be authenticated. Just to give you another example, on the issue of HTTP headers, we can execute that as well. The application will open once more, and it checks the security headers, and since they're not there, the test fails. Let's see if I can show you one for application navigation. For instance, this one that makes passive scanning with ZAP. Here, there's a part that says, and the application is navigated. And what it does is that it will execute the part of the exit that tells it how to navigate. So you see how the application opens up and click is done all over. So we execute it. We put it in a passive scanning mode, and it's done. We are on the search area, and it happens in all sections. Okay, so this is BTD security. I'm going to go back to the presentation. This is what I've told you about, the part of the test. We have tests for SLL, for authorization. It can be extended as we want, and it's quite a useful tool for SECDEVOPS because it's a tool that people in development, security, and operations understand. This is everything that comes by default. It offers reports, and we will see that in the demo as well. And it tells us what failed in each test and why. For instance, the headers that I've mentioned earlier on, these two are not included. So what are we going to do in the demo? What can we introduce for security in that pipeline that we've mentioned earlier on for applications that entail a risk in the company we work for? What I'm going to do in the demo is in the construction phase, we're going to check what's the risk of the application with that service that I've mentioned earlier on. If the risk is above a certain threshold that I'm going to define, the whole construction process will stop. And if it's below, we will allow it to continue. In pre-production, and touching on development with testers, we're going to launch DVD security with ZAP, and we're going to do scanning and active scanning to look for SQL injection. And here you can do whatever security allows you to do. And in the production part, we're going to do another test. I'm going to check the HTTP headers and see and check that it's there. So we're going to launch the pipeline several times, and we will correct these problems live. The pipeline is going to be this. This is a pipeline with a plugin for injections, and we will define different phases, and the idea is that this pipeline is executed before we have a risk adjustment for each spring or for each functionality of group of functionalities that will be implemented. Then developers and testers are going to upload code to GitHub, and when there is a pull request, that should launch the whole pipeline with all the tests. And what is usually done within DevOps, but with our security test as well. So we're going to move ahead with the demo. I'm going to execute the pipeline, and I will run through it as it executes itself. So this is the pipeline. You can see how things are happening. Everything is mocked except for the security part. And what we're doing here, it's launched the DBV security behind or in the background. And in this phase here, we're checking the application risk. And here we're calling the service that I've told you about in Python that tells us what the risk for that application. And then it tells us that the risk is 30%. Here I've given it a threshold of 35, so this application will make it. Then we have this phase in which what we do is we execute BDD security with the test of reverse screening.
I'm going to show it on the pipeline here because you're going to see it better on the code itself. So to implement pipelines in Jenkins in this plugin, we use Groovy in the programming language, where we define, just by putting in the code, the stages of our continuous value delivery pipeline. And Jenkins allows you to define the Jenkins file, put it in your jihad repository, and have a minimum configuration of the build. You can just say, well, get the Jenkins file of the jihad repository and modify anything that has been changed on the spot and put it in the necessary pipeline.
Stages.
So here we have different stages, which is each green circle we have. So we have the first one where the project is launched, where the process is launched. With a pull request, we start building. Then we have the development side, where we check the risk. We go through the unit tests and the integration tests. We have the side where the QA starts doing tests and staging. We have the functional tests, from performance, and this is up. The BDD security is up. That was being executed, as you saw. It copies the configuration we downloaded from the repository of this application to wherever BDD security is installed, and it launches BDD security with the app scan tag. That tag could have been gotten from the risk service. I didn't do it for the demo, but we could have done that. We could have mapped the CWEs and do it from there. But we go to status and we look at the status here, and then we publish the report. So if I go to the pipeline again, we see that this failed. We then go to the next stage, and if I go to the project configuration and the build, we can see the report here. And in the report, the scanning failed. We have these false positives that we indicated earlier. We've seen that with IntelliJ, but there is something that didn't happen, which is that we detected a secure injection on the form and the password. So if you go to the staging, you do logging, like 1 = 1 naive, and on the password I need to paste that, and we can have access to that. So we're going to correct that and go through the pipeline again if we have the time. So to correct that, here I'm using Dockers and containers to simulate this. I'm going to go in the Docker container, which is C4. Here it is. And once we're here, we're going to go to the app, which is a Java application based on JSPs. Here we go to the login form, and here we've already commented the fix. It gets that SQL concentration that has a select from users, word name, username and password. They're there from the user input, and we take that through a parameterized consultancy, and a different statement in the parameters do not make any sense without this. So we map parameter 1, parameter 2, and we execute the query in this way. So with this is corrected, we launch the pipeline, or the pipeline is being executed, and here we check that we have really corrected it. So here we have the new pipeline, it's in execution, we've got the ZAP ones, we go back here, and we try to log in with the user again, just so that you can see what we're doing. We copy this, user A, password 1 = 1, and this fails. So it looks like we corrected it. We go back to the pipeline. Right now we're executing the pipeline. We're executing ZAP again, and what should happen here, and let's see whether it happens, is that that stage should be exceeded because we don't have a secure injection in the application anymore. We're just detecting false positives. We go to the next stage, and here we do the production tests, and here we see that we don't have the HTTP headings, so the build will stop again. Okay, I'd like to show you something else while this is being executed. Regarding the risk service, this would cause a pipeline on the line, and there's a basic service that tells you about the projects you have, and then you put the ID of the project. I'm going to show it to you. Okay, not here, but we can check which is the value of the assets. Here we have different percentages, as well as the trust areas. There are 3, 50, 60, 90. We trust the 50 least, which is more exposed to the internet. And then we have the risk calculation, where we ask for the risk. It tells us risk is 30. So look at what happened here. It goes to the text, we'll see the report next. And here we have the build. We have a staging report all the tests have been passed and everything works fine. But it stops in the next stage, so we can look at the production report and we see that some things did fail. So we're going to correct the production part and execute the pipeline again. So the production part has another container Docker. We simulate the production environment. There's an inverse proxy here with the security headings, so we're going to go to ID and X, and we're going to establish those security headings that are commented here. Okay, so we set them up there, we restart the service. Here it is, and we execute the pipeline again. And we'll go to pipeline 33, and all this should be happening. So I'm going to finish the speech with demo while I execute it, because it's going to take some time, because it does the SQL injection tests once again. But maybe we could do the questions now before we run out of time. If you have any questions, we can comment them now while this is being executed in the back. If you have any questions, please stand up so that we can identify you. Okay. Hi. First of all, thank you much for the speech. It's quite a hard topic, and I'm one of the programmers that is in the slow proportion, in the small proportion. So regarding BDD, I started to look at this, but you did an example with Java. Can it be done with other languages? Initially this is implemented in Java, but if you have developer just next to you, Stephen DeVries, so if you want to increase any information on BDD, you can talk to him. But initially it's Java on Cucumber. Thank you. You're welcome.
Hola, muchísimas gracias.
Hi, thank you very much for showing us so many things, mainly to the security people who do not know that much about development, not to mention SecOps. And I kind of felt that you discarded the static code test, so just app scan, or that you don't think they're easy to integrate in the cycle due to the false positives. I don't know whether you could tell us a bit more about this. Because what is automatable is to assess the code, which is much easier than finding the hole in a dynamic test. Thank you. Thank you. Well, I kind of left it aside because I focus on the other tools of the demo, but depending on the case, it may be more or less useful. In the experience I have with the static analysis code tools, in my former company, we did a test to acquire one, eventually didn't acquire it. Mainly for three reasons. First of all, they were too expensive for the contribution. Secondly, they were too difficult to manage. To execute that, you know, it could be scanning things for 2 to 3 hours to do a code repo for a reasonable size. And thirdly, vulnerabilities found. If they found more things than the open source, or the ones that you may find around, but you know, the results were not that great. So it depends more on the project that you're working on, the technology that you use, and whether you know that what you're going to use is good, rather than they are worth using. That's my point of view, really. Okay, so I'm done. I'll just show you the last slide. All right, thank you. Thank you for coming to my speech.
Por favor, si alguien...
If anyone found our wallet, please take it to reception. And next, we'll have a panel at 6, and questions may be asked from this room, so you can stay here if you want. Thank you.